Here's the use case diagram. A use case diagram, in case you don't know, helps visualize how a participant interacts with the activity platform. In different use case diagrams, you might see different stickmen surrounding the diagram, which represent different users that can access the platform with different levels of access usually. For example, you could have a basic user and then some sort of system administrator. What's interesting about this one is that there's lines between practically every use case and the participant, even the ones that are included from the base use case. This is because it's an interactive web activity. So even though some of the use cases will be included anyway, it still takes a manual user input to actually reach the included use case, meaning that some use cases are compulsory once you've accessed some. So you access a page and then there's a further compulsory included use case that will need to be done before you access the next page, but it is not immediately included. It still takes the user input to do that. Starting from the top, the user first opens the activity welcome page, where they immediately have the option to change the theme from either day mode, light mode, or night mode. Next, the user is given their fake name, which will correspond to all of their data in the database. The activity then extends to take the user to the legalities page, where it's included that the user will have to fill out their consent form. This means that they read through all of the terms and then sign at the bottom and are given a PDF with my signature, the project organizer, and their own signature and the date that they've signed. Next, they move on to the form page, where they can enter all of their demographic information. They can choose to give as much information as they would like to, and there are approximately 12 different attributes for their demographic information, such as gender, age, home ownership, ethnicity, so on. After they've entered that, they can then begin the test. So the test consists of 10 emails, each for the different types of threats in phishing, and a few that represent just normal emails that have no threat. So they choose for each one whether they would like to trust the email or whether they wouldn't be susceptible to it. Finally, they submit the results, which then takes them to the completion page, and if they wish to, they can leave a feedback comment. This is the entity relationship diagram, and an ERD demonstrates what each table will hold, attributes, and how it fits into the database. At its core, the database revolves around the participants and the emails that they're being tested on. To avoid a many-to-many relationship, a weak entity was created called the test table, which for each participant, it stores information on how they tested on each email. It uses a composite key of participant ID and email ID, along with the passed attribute to determine if they passed or failed in determining whether the email should be trusted. The attributes of the participant table and the demographic information that was stored was their ID, so their fake name, their age, gender, marital status, amount of children, how they would define their wealth, whether they're a homeowner or not, their employment status, their occupation, education, religion, ethnicity, nationality, weekly hours of computing, whether they have any visible disabilities, hearing disabilities, disabilities that affect their thinking, disabilities that affect their learning, disabilities that affect their mobility, or their mental state, or their memory, or their communication, or their ability to socialize, each a separate attribute. The attributes in the emails were the email ID, which is the primary key, the description of what each email was. So, for example, one of them was PayPal style email, one of them was Nokia, so on, just what the email actually appears as, so that you can read in the table and you know which test you're reading about. Whether the email was threatening or not, so whether it was testing a threat, this is a true or a false. There were a few emails in there that weren't testing a threat, where this would be false. And the threat itself, so whether that's authority or reward or urgency, so on. In the test table, again, it's just a composite key and then whether they passed or not. These other tables, however, are index tables which were created for each of the non-numerical categories in a participant's demographic information. And these were essential for assigning numeric values to repeating text, saving space, and also allowing the text values to be read via queries pulled from the database. The MySQL implementation of this design uses views to organize all of the relevant data into one table so that it can be used in the machine learning algorithm. Now that I've explained my project in terms of its aims, objectives, and designs, I will now demonstrate the implementation.